So this is problem 20 from Astrophysics. 20 says a star orbiting. Here's the black hole. Here is the Schwarzschild radius, right? We don't even know what that is, right? Okay. And then here's this star, and it's orbiting out here. I don't know, some distance, right? And it is some distance, and it is 89 kilometers from 89 kilometers from a black hole, and its 656 nanometer line is gravitationally redshifted to 712. And then enigmatically in my hint, I changed the 712 to 661 nanometers. Right? It's like, why 661? Well, because apparently I lack attention to detail. Right? It should also be 712, right? Okay. Yeah. It's like, what the heck, right? So it really is 656, which 656 nanometers corresponds to a certain time, a certain period, and that's the proper time, right? And then, but we see it out here being very far away and apparently very large. Okay. We see that at 712, which corresponds to a particular period, and that's the shifted period. Wait, right? It shouldn't be changed in time, original. Well, I'm just trying to make it look like the formula that they give you. Does the formula have the triangle, the delta? Yeah, it's got a little delta thing in it. Don't you remember this? Yeah. There was a delta. That's okay. It was a long, long time ago, like a week, So, okay. So the first thing to do is turn wavelength into period, right, like this. Then we can figure out the Schwarzschild radius. Then we can figure out the mass, can't we? Yeah. So to figure out the time it takes these waves to go by us, the period of the wave, I'm just going to divide length by velocity. Right. This is an advanced concept. I'm really using two formulas. V is f lambda, and then frequency is 1 over period, or period is 1 over frequency, right? And so this period here is 656 e minus 9 divided by 3e8. Isn't that how long it takes it to go by? Yeah. That's how long it is. That's how fast it's going, right? And so this time is, well, I can figure that out with my calculator. 656 e minus 9 divided by 3e8. And this is 2.186 repeating 6 times 10 to the minus 15, right? Okay, seconds. Doesn't take much time at all, right? Mega, right? And then the time here is 712 e minus 9 meters, right, divided by 3e 8 meters per second, right? So that time is, I'm going to store this in A because I'm too lazy to type all that in. And then, no yawning, you cannot do that. E minus 9 divided by 3e8. I'm going to store this in B. So this is 2.3733, right, times 10 to the minus 15. So this is the key. Once you're here, basically, once you get this, it's really not all that hard. This is the tricky bit, right, is realizing that if you know the wavelength, you also know the period that you're observing. So wavelengths of light correspond to periods of time, right? The next step... So all you do is divide by the 2. No, but we're close, right? So this is step 1. Well, no, I'm talking about the step. Yeah, right. And then the next step is we're going to use those two periods. We've got this formula that says, this is the second thing, right, is that, what is it? It's the time is the proper time divided by, or not proper time, but the undilated time over 1 minus, whoops, is that right? Okay. And then this solves down to R being the Schwarzschild radius being R times 1 minus I think we've done that. Have we done that before? Yes. Right, so if you solve it, and you could, generally, most people can't put the numbers in and then just solve it. They have to, like, solve it algebraically. So I just put this guy into there, put that guy up there, squared this, move stuff around. Yeah, several steps there. So the Schwarzschild radius is going to be 89 kilometers times 1 minus, and then this is the delta t is going to be 2.186. repeating, squared, divided by 2.373, and the squared. All right. Notice I don't even need, we kind of devil may care about the 10 to the minus 15th because they're both 10 to the minus 15th. Although to be sure, I'm just going to use the values stored in my, you're standing in front of my camera. Okay. So 89 times 1 minus alpha a squared divided by alpha b squared. And this ends up being 13.449 kilometers. So that's this radius here is 13.449, right? And then what's the formula for the Schwarzschild radius? They're almost there, right? To find the mass, yeah, 2gm over c squared, is that right? So let's do a little algebra here. C squared over gm, or g, 2g. Not screwed. This is the easiest of all the tests we've ever taken. Everybody agrees. You do have to study. What kids say about this test is everybody, if you study for it, it's like the easiest one we've ever done. There's a reason we put it at the end of the year. So, but don't not study. Don't be like, oh, I'm all done. Go and read those sections in the book when it says read. We haven't talked about what's on the test yet, so we'll hold that thought. Okay. So now let's just plug in here 3e8 squared, Schwarzschild radius 0.449 E3, right? Divided by 2 times 6.67 E minus 11, right? So I'm going to store this in C, and I'm going to go 3E8 squared times alpha C raised to the third power, right? I can go CE3, I love this, right? Divided by 2 divided by 6.67 E minus 11. And you get 9.07. And that's roughly 4 still solar masses, a little more. The sun is 1.99 times 10 to the 30th. Is that happy? Are we happy? Yeah. Yeah, I don't know. If you didn't do that, I don't know why you didn't think of those, 3 steps. Yeah, it's kind of a varsity level problem and everything. What the heck?
I don't know, it's definitely a junior varsity level.
I saw that one, though. I was like, I must have this problem, so I just totally copied it.